Yes, Kishor, are you ready? Kishor, Kishor, is everything set?
Sir, am I audible?
Yes, 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 yes.
Yeah, organizer from CIE, please mute yourself. Hello?
एक दोन मिनिटं मला हे चालू
People,
Chaudhari Kishor.
Mr. Datar,
Hello.
Mr. Datar, please mute yourself. Please mute yourself.
Yes.
Hello.
Yeah, good morning all of you and welcome to this Ph.D. Viva House at the Department of Geography, Savitribai Phule.
Recording in progress.
Of course, this is online or virtual mode presentation. Still, on behalf of the Department of Geography, I welcome you all the audience. I welcome the external referee, Principal A.T. Patil. I welcome the guide, Professor Musmade, and all other participants, those who are present here, to observe this open defense or Viva House of Mr. Chaudhari. I welcome you all once again, and with this, I request Professor Musmade to introduce Principal A.T. Patil, as he is the referee, and Principal A.T. Patil, I welcome you on personal behalf and also on the behalf of the Department of Geography, Savitribai Phule University. Sir, please.
Okay, thank you, sir. Good morning to all of you. I'm going to just introduce to today's referee, Dr. Ashok Patil, sir. Honorable referee of today's Viva House, Principal A.T. Patil, Chairman of the Viva House, Professor Dr. Sudhakar Pardeshi, Head of the Department of Geography, Savitribai Phule University, respected Honorable Professor from the department, Honorable Dr. Jyotiram More, Chairman, Board of Studies, Geography, Savitribai Phule University, and all members of the Board of Studies, dignitaries present of this Viva online mode. Welcome to all. I would like to introduce Honorable External Referee of today's Viva, Principal Dr. Ashok Patil, sir. He is a former principal of VES Institute, Sarvajanik Arts and Commerce College, Visarwadi, Taluka and District, Nandurbar. His teaching experience is 33 years in UG level and 5 years in PG level. He holds various positions in the academic career as a member of Senate, Bhainabai Chaudhari, North Maharashtra University, Jalgaon. He had published a book and 33 research papers in well-reputed journals. He has been awarded as a Best Teacher and Best Researcher award. 4 students completed Ph.D. under the guidance of Professor Principal Ashok Patil, sir. Now we will come to the today's research topic, water resource management for sustainable development of agriculture in the Parner Tehsil of Ahmednagar district, Maharashtra. With the permission of today's chairman, Professor Dr. Sudhakar Pardeshi, sir, I am requested to give permission to Mr. Kishor Chaudhari to present his research work in front of you in an online mode. Thank you very much.
Sir, Pardeshi sir, your mic is not on mute.
Yeah. Now, I request Mr. Kishor Chaudhari to present his work. Mr. Kishor, you have time of 40 to 45 minutes. Please try to finish in that, and after that we'll go for open defense. If you have questions, you can raise the questions. Thank you very much.
Thank you, sir. Am I audible? Hello, sir. Am I audible?
Yes, Kishor, yes. Go on.
Very good morning to all. Warmly welcome to Ph.D. Viva Voce examination chaired by Professor Dr. Sudhakar Pardesi, sir, Head Department of Geography, Savitribai Phule, Pune University, Pune. External examiner Professor Dr. Ashok Patil, sir. My research guide Professor Dr. Arjun Musmade, sir. My research center coordinator Professor Dr. Suchitra Pardesi, madam. Head Department of Geography Professor Ramkrishna More Akuri. I once again warmly welcome to all dignitaries present today on the occasion of my virtual Ph.D. Viva Voce examination. My name is Mr. Chaudhari Kishor Chimabau, Ph.D. research scholar from Postgraduate Department and Research Center, Department of Geography, Professor Ramkrishna More College, Akuri, Pune. I am submitting my doctoral thesis for Ph.D. degree in the Faculty of Science and Technology in the subject of Geography. Today, I will present Ph.D. Viva Voce entitled Resource Management for Sustainable Development of Agriculture, the Parner Tahsil of Ahmednagar District, Maharashtra, under the guidance of Professor Dr. Arjun Musmade, Professor and Head Department of Geography, Nikaram Jagannath, Khadki, Pune. Introduction. Developing countries require abundant water and fertile land to increase food production with sustainable. Hello, sir. Someone might interrupt. Hello, sir. Developing countries require abundant water and fertile land to increase food production with sustainable agricultural development. Water resources are vital sources for life that greatly affect potential human development. Water resources have a point of conflict since Middle Ages. Water resources can improve through sustainable agriculture. Irrigation facilities are beneficial for improving agricultural production for sustainable agricultural development. The Maharashtra government has adopted a water resource policy to increase its facilities in large area of the drought-prone belt in the state. Drought-prone areas have 33% chance of drought every year. 16.78% area of the state, 26.27% area of the Ahmednagar district, and 19.53% area of the Parner Tahsil under irrigation facilities. Since the drought-prone zones are the most affected, it has been decided to explore the geographical feasibility of the model in the Tahsil like Parner, which is one of the 92 drought-prone Tahsils in the state as per the report of fact-finding committee and the report of Irrigation Commission in 1973. The key objective of the present research work is to explore water resource management for sustainable development of agriculture and adaptation of cost-effective strategic cropping pattern and water uses action plan model in agriculture. Significance of the study. Agricultural practices have a major impact on the global water cycle. In drought areas, ecosystem productivity depends on water availability and quality. Agriculture and allied sectors account for the highest consumption of fresh water in the country. Scientific water management is an essential for increasing agricultural production and overall sustainable development of agriculture. In India, some of the major challenges in agricultural water management are related to an aging infrastructure and a low water efficiency. Climate change is affecting water availability and is likely to pose a major threat in the coming years. It is most important to meet the growing demand for food grains by adopting environmentally friendly agricultural practices. Agricultural water resource management is the planning, development, distribution and management for optimal use of water resources. Choice of the region. The study area selected for the present research work is Parner Tahsil. Parner Tahsil was selected for specific reasons. Parner Tahsil lies in the rain shadow region to the east of the Western Ghat and receives the least rainfall. From the point of view of geographers, water resource management for sustainable development of agriculture has not properly arranged in the Tahsil. So the research area has not studied in terms of water resource management and agricultural development planning. Parner is one of the few tehsils in the state of Maharashtra showing potential for groundwater recharge. Groundwater level has increased due to efforts in Ralegan Siddhi and Badgaon Amli villages of the Parner tehsil. Choice of the region. The groundwater level has affected by the increasing number of bore wells in recent years. Observations and discussion shows that there has a steady decline in groundwater level over the past few years. Considering all the above aspects, Parner tehsil was selected as the study area or for research to understand the importance of water resource management for sustainable development of agriculture. Study area. The map shows the location of Parner tehsil, district Ahmednagar, state of Maharashtra. Parner tehsil is situated partly in the upper Godavari and Bhima river basin. The tehsil consists of 131 villages spread over an area of 1,933.99 square kilometer. Objectives. The study mainly focuses on the following objectives: to understand available water resources and to quantify the same at village level, to assess present way of utilization of water for agriculture in each village, to carry out cost benefit analysis of major crops in the tehsil to understand value addition through agriculture per unit of available water, to find out cash flow to identify beneficiary sectors due to agricultural activity in the study area, to design a strategy for optimization of cropping pattern which would consume less water without compromising profitability. Hypothesis. The key objective of the present research was to find out the use of water by each crop. The geographical feasibility of any alternative cropping pattern can be studied taking into account. By determining the amount of water resources, a model has been developed to find that keep the profit equal by the using water carefully. The following research questions were taken into account to verify all these. What is the state of scarcity of water in the tehsil? What is its impact? Is it feasible geographically to suggest alternative cropping pattern to reduce the consumption of water for agriculture? Can such pattern be accepted by the local farmers? The following hypotheses were formulated with such questions in mind. The scarcity of water for agriculture can be reduced by optimizing of cropping pattern without compromising profits gained by the farmers. Methodology. The study mainly aims to suggesting water saving cropping pattern should not reduce profitability earned by the farmers. Therefore, it is necessary to adopt quantitative approach in the study. The study takes into account the grassroots level information too. Therefore, it is necessary to adopt macro level approach and collect the data at village level and at farm level whenever necessary. The detail of the methods explained in some relevant chapters. A broad framework may be given as follows. The following methodology has adopted for the purpose of fulfilling each objective of the present research. Objective 1. For carrying out estimation of available water resources in the Parner tehsil have considered for this groundwater, rainfall and transported water used for agriculture in the study area are estimated. For objective 2, to review village-wise irrigation facilities and their impact on agricultural productivity and employment power generation in the tehsil. The cropping pattern in the tehsil has studied at the village level. The present study is based on the village-wise statistics of the current cropping pattern, data obtained from the tehsil agriculture office. The village-wise percentage of net sown area under such crops has considered to understand the field potential of major crops in the study area. For objective 3, to carry out cost-benefit analysis of major crops in study region and find out utilization of water per unit water in agriculture. For objective 4, to find out cash flow to identify beneficiary areas due to agricultural activities in the study area. Calculated cash flow analysis based on inflow and outflow of major crops in the study region. Beneficiary sectors are defined on the basis of cash flow analysis. Mainly, the income of some major crops in the tehsil has a higher inflow than outflow. For objective 5, to design a strategy for optimization of cropping pattern which would consume less water without compromising profitability. Change cropping pattern as per water requirement. The sample action plan had useful for the same. Data sources of data. Information available through various primary and secondary sources has used to fulfill the objectives of the present research. Primary and secondary data sources are listed. Literature review. The literature review on the following topics is reviewed in details. What are resources? Criteria for identification of drought-prone areas, drought-prone zone, socio-economic aspects of drought, soil resources, groundwater, cropping pattern, and irrigation methods. Arrangement of the text. The entire research is divided into 7 chapters. Geographical profile of Paneer Tehsil, administrative setup. The map shows the revenue circles in 2009 and the revised revenue circles in 2020, while the village code map shows the distribution of 131 villages by numbers. Geology. The map shows geology of Paneer Tehsil. Basalt rock is a major feature of the region. It consists mainly of Paleocene Cretaceous convex rocks. Topography. The map shows topography of Paneer Tehsil. The study area is divided into 6 major physiographic divisions. Drainage. The map is showing a river network of Paneer Tehsil. Paneer Tehsil is a division in the upper basin of Bhima and Godavari river. The study area is a part of 4 major river basins and 6 local seasonal rivers. Distribution of soil. The map shows the soil types in Paneer Tehsil. 4 major soil types are found in Paneer Tehsil, which includes basalt soil, coarse soil, clay soil, and shallow ground soil. Climate of study area. Generally, the climate in the Paneer Tehsil is hot and dry. The minimum temperature in the study area is 16 degrees Celsius. In summer, the temperature rises to 45 degrees Celsius. The Paneer Tehsil region receives less rainfall as it is mainly covered by rain shadow zone. The Indian Meteorological Department has only one rain gauge station in the Tehsil. Rainfall of the study area. Rainfall distribution from 1980 to 2020 is shown by eyesight map and parabola map. The area on the southern border of the Tehsil receives the lowest rainfall, while the amount of rainfall increases from the southern border to the northern border region. Vegetation cover in Paneer Tehsil. The map is showing village-wide forest cover area in hectares and percentage. The total area under forest cover is around 0.05%. Out of 131 villages in the Tehsil, 92 villages have 11.05% forest cover area and 39 villages have 0% forest cover area. Socio-economic profile of study area. The bar graph shows land use in Ahmednagar district and Paneer Tehsil area and percentage. The forest cover area in percentage is more in the Tehsil than the district. However, the area under agriculture and cultivable waste of the Tehsil is in percentage is less than the district. Area under irrigation. The bar graph shows the area under irrigation by sources in percentage. It shows that the area under well irrigation is the higher and the area under tank irrigation is the lowest. Unirrigated area. The map shows the village-wide distribution of unirrigated area, hectares and percentage to NSA. Population settlement. The map is showing village-wide settlements. All the 131 inhabited settlements are classified as a rural settlements as per the 2011 census. Only Paneer Nagar Parishad has been recently declared as an urban settlement. Transport network. This map shows the transport network of Paneer Tehsil. Kalyan Nirmal National Highway number 222 and State Highway number 27, 50, 51 and 145 pass through the Tehsil. Generally, the approximate length of metal roads in the Tehsil more than 850 km. Growth rate of population in study area. The bar graph shows population growth rate of a district and Tehsil over a decade in a percentage from 1961 to 2011. Population density of the Tehsil and district. Website showing population density by district and Tehsil from 1961 to 2011. Distribution of male and female agricultural workers. The map showing the village-wide distribution of agricultural workers, total male and female. Cropping pattern. Cropping pattern of study area. The table is showing cropping pattern of study area in 2010, 2015 and 2020. The statistics shows that the area under cereal crop is the highest. The area under cereals and pulses crop has been significant decline between 2010 and 2020. The highest growth is observed in the area under vegetables, sugar canes and fruit crops. The area under wild seeds and fodder crops has also seen a slight increase. The area under other crops has recorded a slight decline but is showing stability. Cropping pattern of the study area. The bar graph showing cropping pattern and change between 2010-15 and 2020 area in percentage to NS. Distribution of cereals. This map shows distribution of cereals in 2010, 15 and 2020 area in percentage to NS. This map showing distribution of pulses in 2010, 15 and 2020 area in percentage to NSA. This map is show distribution of wild seeds in 2010, 15 and 2020 area in percentage to NSA. The map is showing distribution of total fodder crops in 2010, 15 and 2020 area in percentage to net sown area. The map is showing distribution of sugarcane in 2010, 15 and 2020 area in percentage to NSA. This map shows distribution of onion in 2010, 15 and 2020 area in percentage to NSA. This map is showing distribution of fruit crops in 2010, 15 and 2020 area in percentage to NSA. In addition to these crops, cereals like irrigated and unirrigated jawar, bajra, wheat, maize, pulses like tur, moong, urad and gram, oilseeds like groundnut, til, karale, sunflower, soybean, fodder crops like sorghum grass, lucerne grass and napier grass, vegetables like onion, kharif onion, rabi onion and other vegetables, cash crops like cotton, flower crops and spice crops. These crops have been discussed and represented in details by maps as per 2010, 2015 and 2020 statistics. It is not shown here due to lack of time. There should be forgiveness. Cost benefit analysis. At this point, it seems the cost benefit analysis of the various crops being grown in the Tehsil can provide more insight into the problems facing by the farmers. The cost benefit analysis carried out on the basis of sample survey information. The survey provides information on parameters related to agricultural benefits and cost of production, employment potential generated by current cropping systems and unemployed agricultural laborers at the village level. Cost benefit analysis methodology. The map is showing revenue circles and village codes, selection of case study villages and summarization of data. Information collected from more than 180 farmers of selected sample villages. According to the crop composition, 14 well-distributed villages are selected through random sampling method to collect primary information. Expenditure incurred for various operations like tillage, fertilizers, seeds, planting and harvesting is considered as final charges. A summary of various operations has been prepared to understand the cost per hectare for each major crops in the Tehsil. Major crops. The first step is to identify the major crops in the Tehsil. Cost structure. A structured questionnaire has developed to find out the cost of various operations ranging from planting to harvesting and selling in the market. Water requirement for cropping pattern. As per physical structure and local climate, required water for crops database have obtained and the crop wise and village wise water deficit and surplus availability is shown in the table and maps. Planning for water deficit villages. Water scarcity villages in the Tehsil are separated on the basis of availability of water resources and water requirement of different crops. Employment available. The primary survey has provided data on the employment potential of each crop in Tehsil. The information of these Tehsil data is compared with the number of cultivators and agricultural laborers in the village-wise census data. According to the census definition, the main worker is any person who has at least 180 working days in a year. As per some previous studies, agricultural workers need to get at least 300 days of profitable employment to meet their needs. Therefore, employment of at least 300 days is considered as employment for the year. First formula is used to calculate male employment potential for a particular crop, and second formula is used to calculate female employment potential for particular crop. First two formulas are used to calculate male and female employment potential for particular village and particular crop. Last two formulas are used to calculate male and female employment potential for tehsil. Trial and error method. The first prevailing cropping pattern can be changed by taking 3 crops of both kharif and rabi seasons in the field of study and changing them to reduce the area under onion by 10% and sugarcane by 15% per hectare. Available irrigation water can be used for all these two alternative crops. This will significantly reduce the need of water, and the available water will be used to increase the area under irrigation. Thus, if the right strategy is implemented, the following situation will arise: reduce the need on the water resources, overall agricultural net product increase, local unemployed workers are employed, and the opportunities available through the agricultural sectors. Cash flow analysis. The total income of the farmers has analyzed to understand the cash flow after getting the statistics of expenditure on cultivation of major crops in the study area. In the present study, the following factors have considered to cover the cost of cash flow. Cash inflow parameters: wages given to women workers, wages given to male workers, profit margin earned by cultivators. Cash outflow parameters: cost of seeds, fertilizers and pesticides, cost of packing material out from urban sectors, cost of fuel such as electric bill, diesel or hiring tractor and technology. Thus, the share of income which remain in the tehsil and the share which goes out of the tehsil is estimated on the basis of expenditure structure. In this research, it has been estimated for each village for tehsil. Cost of crop cultivations. In this table, the cost of various operations in the field of unirrigated jawar cultivation has calculated. The figure in the table shows that the average total production cost of unirrigated jawar is rupees 32,450. The total average cost of labor is rupees 15,550, while the other total expenditure is rupees 16,930. Cost benefit statistics of unirrigated jawar crop shows that most of the costs in various operations on harvesting and threshing. Based on the cost structure, output and cash flow analysis of unirrigated jawar cultivation is calculated. The output of unirrigated jawar cultivation table indicates that the cost of unirrigated jawar cultivation is 32,450 per hectare, and the net output from the unirrigated jawar cultivation, including the cost of fodder, is rupees 11,250 per hectare. The net profit from the unirrigated jawar cultivation is rupees 7,000 per hectare. The unirrigated jawar cultivation is required 18 males and 42 females per hectare, and daily wages for male workers rupees 300 and for female workers rupees 250 rupees. Cash flow analysis of the unirrigated jawar cultivation. It is observed that the profit earned by the farmer due to the cultivation of unirrigated jawar is about 17.174%. The cash inflow in the case of unirrigated jawar is 78.45%, and the cash outflow in unirrigated jawar cultivation is only 3.80%. In addition to this crop, irrigated jawar, unirrigated and irrigated bajra, wheat, maize and moong, gram, tur, urad, groundnut, soybean, pea, vegetable and fruit crops. Cost benefit analysis and cash flow analysis are calculated for all these crops. But it is not possible to show due to lack of time. There should be forgiveness. Cash flow analysis, but all major crops cash flow analysis is calculated in this table. The table is showing cash flow analysis. The cash flow analysis technique is very useful to understanding the crop-wise rupees incoming and outgoing in this testing. The cash flow analysis of major crops in the study area was revealed from this table. The cash outflow is more in the case of crops like fruits, followed by sugarcane, onion and groundnut. Also the cash inflow is more in the case of crops like fruits, followed by sugarcane, wheat, irrigated and vegetables. The profit is more in the case of crops like fruit, sugarcane, followed by onion, vegetables and jawar area. Water resources. The bar graph is showing process of irrigation in the tehsil percentage. The ratio of irrigated area under wells to the net zone area is 11.22% and ranked first among the total sources of irrigation. The ratio of irrigated area under government canal to the net zone area is 6.26% and ranks second among the total sources of irrigation. The ratio of irrigated area under wells to the net zone area is 1.06% and ranked third among the total sources of irrigation. The map and table is showing village-wise area under Kupli irrigation project in hectares. Only 27 villages in the west, south border areas of the under irrigation project. The map shows the distribution of wells, percentage of wells and density of wells. There are 29,444 wells in 131 villages of the tehsil. Out of these, only 15,600 wells are registered. The village-wise average density of wells in the tehsil is 6. The map shows general distribution of farm ponds and percentage-wise distribution of farm ponds. The total number of farm ponds used in the tehsil is 1,576.
मेल आईडी का पासवर्ड चेंज करने के लिए campus.uniform.ac.in वाली साइट है ना
1,120.
पता नहीं
The number of unsubsidized or self-financed farm ponds is 3,456. The bar graph is showing the area under medium irrigation projects in the tehsil in hectares.
campus.uniform.ac
8 medium irrigation projects in tehsil. The irrigation potential of 8 medium irrigation projects in 6,544 hectares and total water storage capacity is 1,235.75 million cubic feet.
मोबाइल में बहुत है
The map is showing village-wise distribution of population tanks, water storage capacity of population tanks in million cubic meter and irrigation capacity is in hectares. Total 228 population tanks in tehsil. Total water storage capacity is 32.08 million cubic meter.
हाँ
The map shows the village lake water storage capacity of million cubic meter and irrigation capacity under village lake in hectares. The total number of village lakes in the tehsil is 56. That's water storage
Chaudhary
capacity.
sir, please, Selar, please mute.
Sir, someone is interrupt me.
Selar, Sai Selar, please mute.
Is in number of times.
Kishor Chaudhary.
The map shows distribution of village lake, water storage capacity of village lake in million cubic meter and irrigation capacity and hectares. The map is showing village-wise distribution of storage tanks, water storage capacity of storage tank in million cubic meter and irrigation capacity under storage tank in hectares. Total 143 storage tanks in tehsil. The water storage capacity is 5.98 million cubic meter and about 1,555 hectare area in 67 villages is indirectly irrigated under storage tanks. The map shows the distribution of KT wells, water storage capacity of KT wells in million cubic meter, irrigation capacity under KT wells in hectares. Total number of KT wells in tehsil is 54. The water storage capacity is 4.63 million cubic meter and potential to indirectly irrigate an area of 960 hectares in 29 villages. The map is showing village-wide distribution of CNB, water storage capacity of CNB in million cubic meter and irrigation capacity under CNB in hectares. Total number of CNB in tehsil is 171. The water storage capacity is 9.06 million cubic meter and has the potential to indirectly irrigate an area of 1,768 hectares in 81 villages. Rainwater was calculated with the help of this formula. Considering the average rainfall in the study area, the total rainfall in the tehsil is approximately 41,914.98 meter hectares. Afterward, subtracting 50% loss to evaporation and 10% infiltration as recommended by MISRA in 1978. Appraisal of water resources. First table showing frequency distribution of village-wide villages according to available of water in meter hectare. 100 villages in the tehsil have water availability up to 600 meter hectare, while 29 villages have water availability ranging from 600 to 2,400 meter hectare. And only 2 villages have water availability from 2,400 to 3,000 meter hectare. Second table showing frequency distribution of villages according to requirement of water in meter hectare. 106 villages in the Tehsil required water resources up to 1,400 meter hectare, while 24 villages required water resources ranging from 1,400 to 5,600 meter hectare, and 1 village required water resources from 5,600 to 7,000 meter hectare. Surplus and deficit of water. The map is showing village-wise available water in meter hectare, requirement of water in meter hectare, and surplus deficit of water in meter hectare. The total water available in the study area is 62,752.32 meter hectare. The requirement of water for the current cropping pattern is 1,32,786.98 meter hectare. Water deficit is 69,974.66 meter hectare. A balanced analysis of water resources and their uses in agriculture shows that about 6 villages are showing a positive balance and 125 villages are showing a negative balance. Crop-wise water requirement and income. The table is showing crop-wise water requirement and income. The highest water requirement is observed for onion and sugarcane. Figure shows that the highest contribution of fruit crops per hectare to agriculture income in the Tehsil was observed, followed by sugarcane, onion and groundnut. The highest net profit in rupees is observed for fruit crops per hectare, followed by sugarcane and onion. The most important and the highest net profit in meter hectare is observed for till crop per hectare, followed by karali and groundnut. Crop-wise employment generation. The table is showing crop-wise employment generation. The total number of workers depending on agriculture in the Tehsil is about 9,51,044, including 4,68 males workers and 5,50,976 female workers. It is interesting to see employment generated by different crops per unit of water resources. It is observed that employment per meter hectare is maximum for the crops like groundnut, followed by soybean, irrigated bajra, irrigated jawar, irrigated wheat and gram. Strategic plan 1. Strategy for strategic cropping pattern. Optimization of cropping pattern. Water resources and watershed management. Employment generation. Income should not be compromised. Reduced outgoing income. Table showing strategic cropping pattern 1. The area under sugarcane was reduced by 15% and onion crop by 10%. This may lead to a 3-fold increase in the hectare of cereal crops pulses instead of sugarcane and double that of onion crop. Increase in kharif season crops. In first strategic cropping pattern, a reduction in water demand has been reported due to the suggested areas in suggested increase in area under crops. Although the employment opportunities are increasing, the income is seen to be decreasing. The table showing strategic cropping pattern 2. Again, the area under sugarcane and onion crops reduced by 15% and 10% respectively. No increase or decrease in area under crops is suggested, but the decrease in demand for water resources is noted. Large increase and slight decrease in kharif crops. Employment opportunities and income seems to be decreasing. The table showing cropping pattern 3. Again, the sugarcane crop was reduced by 15% and onion by 10%. Employment opportunities and income seems to be increasing. So this strategic cropping pattern seems more convenient. Action plan for water use water at village level. This action plan for Nigos village. For this, the concept of water credit has suggested in the villages under the study area, according to which water loan will be exchanged between farmers who use more water than the equitable distribution of water resources and farmers who use less water for equal distribution. Nigos is a village situated in the southern border of the Tehsil on the bank of river Kukdi. According to the current cropping pattern of the village, the net sown area is about 3,672 hectares. Total available water from all sources is 2,759.41 meter hectare. Total water requirement as per current cropping pattern is 6,851.58 meter hectare. Water deficit means required water minus the available water is 4,992.17 meter hectare. With the help of this formula, the availability of water per hectare in Nigos village is calculated. The water availability per hectare in Nigos village is 0.75 meter hectare. It shows that normally 0.75 meter hectare for per hectare of water is available in Nigos village in a year. As an example, let us consider two major crops grown in this village which are also environmentally sound. If a farmer wants to cultivate jawar under irrigation, he needs 0.525 meter hectare of water for 1 hectare of irrigated jawar. It means after subtracting 0.525 meter hectare water for irrigated jawar crop from the 0.75 meter hectare available water to him or 1 hectare area, 0.225 meter hectare water will be surplus. Another farmer wants to cultivate sugarcane, he needs 4.05 meter hectare water for 1 hectare of sugarcane. It means after subtracting 4.05 meter hectare water for sugarcane crop from the 0.75 meter hectare available water to him for 1 hectare area, 3.3 meter hectare water will be deficit. Which suggests farmers in Nigos village who use more than 0.75 meter hectare of water per hectare will have to pay for more water resources. In contrast, those farmers in Nigos village who use less than 0.75 meter hectare of water per hectare will earn money by selling their remaining water credit to those who use more water resources. If this tool is used, there will be a time when some farmers who have a good advantage of geographical conditions will be able to pay more for cash crops that require more water, and those who grow less water crops like fruit grains will be able to earn money by selling their remaining water credit. Eventually, the optimal cropping pattern introduced for sustainable development of agriculture will become stable in a village and place. Summary: 8 minor irrigation projects in the Barnard Tehsil. Black soil covers 91.97% of the area, which is highest in the Tehsil. 39 villages have 0% forest cover area. 1 national and 5 state highways pass through Barnard Tehsil. The sex ratio of the Tehsil increased from 1971 to 1981, but has been steadily decreasing since then. From 2010 to 2020, the area under cereals and pulses has declined, and the area under vegetables has increased significantly. The area under irrigated jawar was decreased, and bajra was increased slightly from 2010 to 2020. The area under cereals was declined sharply from 2010 to 2020. 29,444 wells and 4,576 farm ponds in the Tehsil. Only 19.53% area of NSA is under irrigation, and from 2010 to 2020, the area under onion crop and vegetables increased rapidly. The total water storage capacity of collection tanks, village tanks, KTVs, CNVs and storage tanks in the Tehsil is 53.45 million cubic meter. Canals account for 20.17% of total water resources. 8 medium irrigation projects account water storage capacity of 1,235.75 million cubic meter. Major findings: 12,657.80 meter hectare is brought about from outside of the study area. The total available water resources for a normal rainy year is estimated at 62,762.32 meter hectare for agriculture. It is estimated the annual water requirement under current cropping pattern is 1,32,727 meter hectare. The current cropping pattern creates a water deficit of 69,974.66 meter hectare for agriculture. Even if micro irrigation systems are widely developed, their use in the study area is still limited. The unlimited use of hybrid seeds, fertilizers, and pesticides seems to increase rather than decrease water demand for crops. Water resources used in sugarcane and onion crop takes 20.49% and 31.94% respectively. Yet the NSA covered in respective crops is 3.96% and 18.38%. The water resources used for sugarcane crop seems inappropriate in extravagant considering NSA cover. Water scarcity is more prevalent in villages in the western and southeastern part of the study area where water sources are ample. Doki, Gadadipur, Davalpuri, Venkute, Tas and Pokri villages show surplus water under current cropping pattern despite lack of canal irrigation facility. The increased number and depth of bore wells is adversely affecting groundwater levels. Sugarcane and onion affect less employment opportunities than crops like groundnut, soybean, wheat and gram. Limitations. Any research work cannot be from errors related to research methods, database and field studies. Primary information is collected in the form of questionnaires and personal interviews. 3 probable errors in collecting primary data. Firstly, while filling the information in the questionnaire provided by the farmers. Second, sampling errors as it is not feasible to complete questionnaires or conduct interviews in the all study region. Thirdly, the personal privacy and confidentiality of the information provided by farmers, misleading information will be provided. An attempt has made to reduce the errors by discussing subject with resource persons. If the 2021 census was available, a more realistic research would have done. The cost benefit and cash flow analysis presented in the thesis is entirely based on the field survey of farmers, might be misleading information. Water resources available for agriculture use is estimated based on the hectare area under various crops cultivated using irrigation facilities. These limitations can be mitigated by making some changes in the study methods in scope of future further studies. It can be suggested that a detailed study of each village will enable the government to implement micro irrigation schemes for each farmer and new irrigation strategy to better uses of water. The micro level approach is adopted in the current research, so this approach can be useful in motivating geographers and scholars to study on micro level in various fields. The crop optimization concept is the best planning tool to achieve sustainable agricultural development based on available water sources. A similar concept may be useful in other branches of human geography. Cost-benefit analysis has found to be a useful technique for identifying problems in agricultural structure and is used for cash flow analysis. The present work can be applied to any circle and tertiary level studies in agricultural and economic geography. It helps to analyze agricultural composition of different places under different conditions about tribal, high rainfall, semi-arid and drought-affected regions. Considering the wide scope of further studies, the researchers intended to undertake a major research project in the field of designing agro ecosystem for the development of local people based on the evaluation of all types of resources. Relevance of this study. Current research is a top priority for planners in sustainable agriculture, rainfall, groundwater and cropping pattern development. The present research seeks to recognize geographical areas of low agricultural development and to understand its causes. The research can provide appropriate guidelines for formulating various new agricultural schemes and reviving old schemes of the government. Thus, the present research is a sociological study of rural areas in the perennially drought-prone regions of Maharashtra state, as well as agricultural areas with similar conditions and problems across the globe, including India. Conclusion. The current research with proper database and micro-level study found that agricultural environment is weak due to uneven distribution of water and water scarcity. It suggests alternative cropping pattern and appropriate planning strategies to mitigate water scarcity-related problems. It has observed that due to the adaptation of strategic cropping pattern, a village can transform from underwater status to a village with adequate water supply without compromising on agricultural income. It is further analyzed that such cropping practices may reduce the flow of income from the tehsil and hence alternative cropping practices may be suggested to accelerate agricultural development. Water is the currency of agriculture, so one cannot imagine farming without water. In the light of the objectives, the hypothesis of the study, the scarcity of water for agriculture can be reduced by optimizing of cropping pattern without compromising profits gained by the farmers. Is accepted based on methodology and database used in the present research work. Thank you so much.
Yes, sir. Thank you for finishing this because it is
हॅलो
topic is the research.
आवाज येत नाही काय? अच्छा आवाज येत नाही.
Actually, I will now.
Vice is not correct, sir.
Thank you.
हॅलो सर हॅलो सर सर आवाज येत नाही.
So I will repeat this. Now, is it audible now?
येस सर
सर तुमचा आवाज येत नाही व्यवस्थित.
प्रोफेसर परदेशी सर आपला आवाज येत नाही.
Yeah, is it audible now?
नो
Hello?
सर
It's a problem.
I think Patil sir has joined your two connections. You are on. Both
Yes.
mics are on.
येस सर
Is it audible now?
कारण इको होतोय तुमचा आवाज. पाटील सर
हॅलो हॅलो
पाटील सर तुमचे दोन अकाउंट दोन आहेत त्यामुळे आवाज
कॅम आय ऑडिबल सर
एक कुठला तरी बंद करायचं.
पाटील सर तुमचे दोन मोबाईल आणि लॅपटॉप दोन्ही चालू आहे. एक कुठलं तरी बंद करा म्हणजे आवाज क्लिअर येईल. पाटील सर
ओके.
एक बंद करा म्हणजे मग आवाज क्लिअर येईल.
Right.
ओके परदेश सर.
Now, am I audible now?
येस
Yes,
येस
sir.
परदेश सर प्लीज.
Thank you, Mr. Kishor. Limited. It was nice presentation from myself. I'll maybe make a comments later. But now, this topic is open for discussion. If you have any questions, please
केलंय ना
questions and
आवाज
comments
माईक बंद माईक
that are relevant to
ऑडिओ चालू करा. व्हिडिओ
from the participant audience.
येस सर
From the participants. Have any observations, comments? Well,
Sir, can I can say introduce myself.
sir, will come later.
After work. Okay. येत नाही सर आवाज क्लिअर नाही येत सर.
आवाज क्लिअर येत नाही.
हॅलो
Hello. Am I audible now?
हां येस सर.
So from the audience, if there is any questions, suggestions, or any comment, observations, please go ahead. We have very little time, and then I'll come to this party for his observations, comment as a referee. I think there is no comment, question.
Can I ask Can I ask sir some queries?
Yeah, obviously, sir. You will be.
Yes, sir. Yes, sir. Well done, Mr. Chaudhary. You are presenting so fluently, but I have some queries in your presentation. First thing is that you mentioned in your research work there are 5 objectives you can study for your research work. Okay, sir. Please, if you can show me the second objectives, which one, like this, to assess the present way of utilization of water for agriculture in each village. This is your second objective. My question is that how you can apply second objective in your research work. Which type of data you can use for your second objective. Mr. Chaudhary, can you understand?
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
In the first topic, you are given the objectives.
Sure.
Yes, sir. Yes, sir.
Sir, asking something to you.
Yes, sir. I was showing objective. I will answer.
I can read this. You can only understand this. To assess.
Second criteria, second objective.
Second objective, to assess present way of utilization of water for agriculture in each village. This is your second object.
Yes,
But
yes.
but the second object explanation is another. There is the explanation on irrigation, not there is not the agriculture. How you can apply this second objective in your research work? Which criteria you can follow this?
Sir, I have collected data from Tehsil Office of Agricultural Cropping Pattern.
Yeah.
Various crops are cultivated in one village, and the fact finding committee are saying that sometimes some crops are irrigated and some crops are unirrigated. The particular crops water requirement is decided by fact finding committee, and the area under particular crop I have analyzed with the help of this requirement of water for particular crop. If the crop is irrigated or unirrigated on the basis.
But your explanation, you show the diagram and also tables. There is that the cropping pattern mostly change, dramatically change after 2015. Why so?
Sir, irrigation facilities are increased, and also cash crops will be introduced. A small account of micro irrigations are being introduced. That's why the area of
for example, micro irrigation.
For example, my area of food grains converted into food crops.
Second question is that Mr. Kishor, you have formulated very nice hypothesis in your work. Your hypothesis is very good. I have read. You know about your hypothesis. How is it possible? Prove your hypothesis. Is it accepted or rejected?
Yes, sir. It is accepted.
Yes, it is accepted. So
yes,
why is it so accepted? Which variables you can use for this?
Sir, for example, 1 hectare sugarcane required 4.05 meter hectare of water, and sugarcane is cultivated in annual form. If sugarcane cultivated area is reduced, and this water is food grains are cultivated on this area, the water is available for 4 hectare area for like jawar crop.
Yeah.
Then the jawar crop have it is beneficiary for income and also increasing employment power generation than the sugarcane. And the productivity is increasing in the jawar crop. But if area is under sugarcane crop, year by year, productivity of agricultural land will be decreased.
Each and every questionnaire you can take on the random sampling method used for your questionnaire.
Yes, sir.
I
It's breaking.
Your department about the internet. We all about this. Basically, Kishor is a very nice research student. He is suffering from the physical problem, but he cooperates very nicely in last 5 or 6 years. Last 2 days, he is suffering from viral infection. Lot of suggestions, some suggestions from external referee, yourself, in our research. Thank you about all cooperation from all referees from outside the state, outside the country, and outside the university. Okay, you just have your opinion, sir.
Now, am I audible now?
Yes, sir.
Right. So, based on the observations by the external laboratories and the guides input I have gone through, there was one comment present. Okay. Please make sure that whatever question is asked, right? Its overall presentation was good. All the reports are satisfactory. So, the reports I have got, and on the basis of reports given by the referee and report by guide, I recommend name of Mr. Kishor Chaudhary of scientific. Congratulations, Kishor.
Thank you so much, sir. I think my voice is not clear. I am suffering from some infection in my throat.
It's okay. It's okay, sir. It's okay. It's okay.
Thank you so much, sir.
Yes, sir.
Yes, sir. Can I conclude? Can I conclude now?
Sir, it's already done. It's already done.
Okay. Congratulations, sir, Kishor Chaudhary. You are
रेकॉर्डिंग
presenting-
बंद करा, रेकॉर्डिंग बंद करा.
Recording. Hello.
किशोर and मुसमाडे sir, heartily
Yes, sir.
congratulations.
Recording stopped.
Thank you, sir. Thank you very much.
अभिनंदन किशोर, अभिनंदन मुसमाडे सर.
Thank you so much. sir.
खूपच छान प्रेझेंटेशन झालं किशोर. थोडंसं डिस्टर्बन्स झालं.
Congratulations, Mr. Arjun Musmade, sir. Sir, Dr. Kishor Chaudhary, sir. You are our Ph.D. from Savitribai, Pune University. We have congratulated you. Thank you.
Thank you, sir.
कॉंग्रॅच्युलेशन चौधरी सर आणि मुसमाडे सर.
Thank you.
Congratulations, Dr. Arjun Musmade sir and Dr. Kishor sir.
Thank you, ma'am.
Congratulations चौधरी सर.
Congratulations, Kishor sir.
Also congratulations Dr. Arjun Musmade sir.
Chairman.
डॉक्टर मुसमाडे सर, कॉंग्रॅच्युलेशन. खूप छान झालं सर. आपण थांबूया सर.
Thank you all for joining and very much.
Thank you for this, sir. Thank you.
Thank you so much for this, sir, and Dr. Musmade sir and Patil sir.
Congratulations, Chaudhary sir, Musmade sir.
Thank you so much, madam.
सर अभिनंदन.
खूप धन्यवाद.
Hello, Jyotirao sir. अभिनंदन.
डॉक्टर किशोर. हा हॅलो, मी वायवा करतोय. हॅलो,
आपण ते पाठ